Let's find common denominators now. Remember that a common denominator is a denominator, or is a number or an expression that other expressions divide into. And the smallest we can make that, the happier we're going to be. And so we're going to start with two fairly simple examples, or expressions. And we want to find the common denominator between these. And so we need to find the smallest denominator such that 3x squared y squared and 6xy cubed divide into it evenly with no remainder. And so we're going to start with, when there's no plus signs, we just start with the numbers. The LCD between 3 and 6 is 6, because 3 divides into 6 and 6 divides into 6. Between the x squared and the x, we pick the higher power, so it's x squared. Between the y squared and the y cubed, we do the same thing, and we get y cubed. So my LCD of 4 over 3x squared y squared and 5 over 6x y cubed is 6x squared y cubed. As another example, suppose we have x minus 1 over x squared plus 4x plus 3 and 3x minus 5 over x cubed plus 2x squared plus x. And so we're going to factor just our denominators. Notice we're ignoring the numerators completely. This factors as x plus 3 and x plus 1. And this factors first as x squared, x times x squared plus 2x plus 1, which is a perfect square trinomial of x plus 1 squared. So now we look at what our LCD is. And our LCD starts with an x by itself. And then we look for what's in common. They both have an x plus 1, but our second one has a square, so we pick the higher power, because that'll have enough that the 1 is represented. And then we just include what's only in the 1, and that's the x plus 3. So my LCD is x times x plus 1 squared times x plus 3. And the order doesn't matter too much if I change it around, but the fact that I have all of the pieces does. And when I divide, notice that x plus 3 times x plus 1 divided into this leaves an x and an x plus 1. And then when I divide x times x plus 1 squared into this, I'm left with just an x plus 3. So I get everything to divide out when I divide the small ones into the LCD. The last example I want to look at is 4x minus 3 over x squared minus 5x minus 14 and x plus 1 over x squared plus 4x plus 4. So again, we factor, and this is x minus 7, x plus 2, and this is a perfect square trinomial, x plus 2 squared. So we start our LCD with what they have in common. They both have x plus 2's, but one's a 1 and one's a 2. We always grab the bigger power when we're looking for LCDs. Then we just need to grab whoever's missing, and that's the x minus 7. We found now our LCD of our two rational expressions.